Hi everyone, this is group 2 and we will be talking about glassmaking and glassmaking processes. We will begin with the intro and history of glassmaking, glass properties, old processes in manufacturing, new/current technologies in manufacturing, benefits and drawbacks, and finally conclusion.
Glassworking is the art of shaping glass into useful or decorative items. It's a craft that has been part of human life for thousands of years. From making tools and containers to create beautiful artworks, people have always found creative ways to work with glass. What makes glassworking special is how it's combined art, science, and technology. Artists and craftsmen use heats, tools, and precise techniques to turn metal glass into unique shapes and design. Over time, these methods have become more advanced and creative. Glassworking began as early as 3500 BCE in ancient Mesopotamia and Egypt. At first, people made a small decorative items like beads, which were often used for jewelry and decoration. Interestingly, glass was first discovered by ancient during metalworking, but over time it became a craft of its own with the skilled artisans learning how to shape and color glass in purpose. By the 15th centuries BCE, Egyptian craftsmen developed a method called core forming to make hollow glass containers. They also use metal oxides to add bright colors, making the glass look like valuable gemstones. Around the first century BCE, a new technique called glassworking or glass blowing was developed in the Syro-Palestinian region. This method changed the way glass was made and allowed for faster and more creative production. Glass blowing works by blowing air through a hollow tube into hot metal glass. This made it easier to shape glass into different forms and led to more variety in design and styles. The Roman improved the technique by adding molded blowing, which helped create details, patterns, and even architectural pieces. Thanks for these innovations, glass became more affordable and widely available through the Roman Empire. After the fall of Roman Empire, glassmaking continued to grow in different parts of the world. The, the Byzantine Empire helped keep Roman glass techniques alive, while Western Europe became known to beautiful stained glass windows in churches and cathedrals. During the Renaissance, the island of Murano in Venice became one of the most important centers of glass making. Craftsmen there created clear glass called cristallo and developed the detailed style like filigree and enamel painting. Murano's glasses guarded their techniques carefully, keeping them a secret of the rest of the world. This Ciceri helped Murano build a strong reputation for production for some of the finest glass in history. Persian glassmakers made important contribution to the art glass working. One of their key techniques was wheel cutting, which allowed them to carve detailed geometric patterns into the glass. They also became known for creating very clear and colorful glass using great shades of blue, green, and yellow. Their work stood out for its brightness and beauty. Persian glass, Persian glass was often shaped into unique form like flags, blouse, and goblets with ribbed design. These styles and techniques had a lasting influence on glassmaking in the Islamic world, as well as uh, Byzantine and European tradition. That was the history of glassworking, and now we will talk about chemical, electrical, and mechanical properties. We will also talk about old and new manufacturing benefits and uses of modern glasses and more.
Okay, so now I'll start talking about properties that should be considered while doing glasswork. So this would be chemical, electrical, mechanical, thermal, and optical properties. Okay, so beginning with chemical properties, the main component that can be found in glass is silica sand, which has a high melting point. Other properties that can be found in glass would be soda or sodium oxide that lowers the melting point of silica, lime or calcium oxide that determines the hardness and the durability of the glass, magnesia, which increases the melt velocity, viscosity, and the crystallization temperature, and alumina, which reduces the coefficient of thermal expansion. As for electrical properties, glass is usually an insulator and it has a high resistance towards conducting electricity. Because of this case, usually there could be modifications made to the glass to make it become more conductive. These modifications include processes like including other materials into the glass, including lead oxide and boron oxide. And other applications would be glass and metal seals, which is basically a joining of glass and metal surfaces together. And also electrochromic glass, which is just basically glass that can change its transparency due to its response for electrical voltage. For mechanical properties, so this is more taking into consideration like the durability and the hardness of the glass, which determines like the thickness and etc. So some elements that contribute to this would be silicon dioxide, which is the main component for the structural integrity of most glasses, calcium and magnesium, which are stabilizers that help improve the durability of glass, and sodium and potassium, which is actually the opposite, and it helps kind of weaken those structures for like a softer glass. For thermal properties to be considered would be its heat conductivity, also as CTE or coefficient of thermal expansion. This is extremely important when it comes to glass working because glass is not very expandable. Um, so it's something to be taken into consideration when working with this material. It also determines the amount of shrinkage that could be occurring during manufacturing process. Its last component or property would be optical. So these are properties that determine how much light is allowed to pass through the glass. Reflectivity is also another measurement that can be taken into account during manufacturing. How shiny it is or how much light is actually allowed to bounce off from the surface.
Yeah, so now we move on to traditional or old manufacturing techniques for glass making. So first one we have is glass blowing, which is where glass is molten on the end of a pipe, and then air is then blown into the glass to create a bubble. The bubble is then formed into a vase or other glassware that can store water or something like this. And then we have casting, which is molten glass is poured into molds to create solid objects. And this is used to create jewelry or other glass sculptures. The benefits of casting would be that you can have very intricate designs because the cast that is used when the glass is poured in can have any small design or can even make larger sculptures from glass. And another one would be slumping, which has glass sheets are heated and rested over different objects, causing the glass to slump and solidify. This is used to make bowls, plates, and other curved objects, typically used for like eating utensils.
So I'll be talking about some of the new technologies that are transforming how glass is made today. The float glass process is one of the most common methods for making flat glass. In this process, molten glass is poured onto a bed of liquid tin, which allows it to spread out evenly and form super smooth flat sheets. This type of glass is used in things like windows and mirrors. The fusion draw process, which is used to create very thin and high quality glass, especially for screens like phones and TVs. The edges are super clean because the glass never touches any solid surface while being formed. Another useful innovation is the smart glass. This type of glass changes from clear to dark when electricity is applied. You might have seen it in like modern cars or buildings where it helps with privacy and also saves energy. And finally, we have 3D glass printing, which is still pretty new. It works just like 3D printing with plastic, but with glass. It allows for super custom designs and being used in art, medicine, and even in tech industries. And then modern glass technologies brings a lot of benefits to our society today. First, the quality is a lot better, so there's less waste. Machines can make the glass stronger and smoother, and the process is more efficient. Also, we now have more choices and creative uses for glass. Smart glass and 3D printing allow for unique designs that weren't possible before. Some glass also come with special coatings that block UV rays or heat, which makes it more useful in different environments. We see these types of glass in everyday life, in buildings with energy saving windows, in phones and TVs with strong scratch resistant screens, and in cars where glass can self dim for comfort and safety. So, overall, these new advancements make glass more useful, more flexible, and better suited to modern needs.
So with every material, you're going to have, pros and cons to each type of thing you're trying to make. And glass is no exception. So glass is very strong in the compressive forces, but it's brittle and can crack easily when faced with tension. So when you're designing glass, you specifically want it to face more compression than tension in whatever application you're putting it in. It also has low impact resistance, so it can easily chip when it's faced with a hard surface, or if it, bumps into something, it could easily start to crack or fracture. So that's another thing to look out for. And having sharp corners on edges of glass is a really good way to make high stress points very, very like focused. So if you notice when you have a coffee table and there's glass on it, they always chamfer the edges to spread out that amount of force that would have hit that corner to evenly distribute it and to reduce the amount of cracks that could happen when it bumps into it. So with all the properties that glass has, it really shines when it comes to its thermal properties. So you see it used on cars for its visibility and optical properties, and it can absorb a lot of the heat. In the kitchen, you have your oven doors that are made of glass. You have a lot of ceramic pots and pans or glass lids that you can put inside the oven too. And you also have solar panels on top of houses and, in fields nowadays because it can absorb that heat easily and still keep going without breaking down to radiation like plastic or wood naturally does. So with all those things in mind, you kind of want to use the benefits of glass to strengthen it even further. So glass, when it's typically made, it will have a little bit of defects. It'll have a little bit of a roughness on the surface or corners that aren't perfectly, straight, or it could be brittle. So with this, we use its highest advantage to benefit it more. Because it's so good at resisting heat, you actually go through a process called annealing. And annealing is when you heat up a glass to a certain point, similar to metals. You heat it up to a very specific point, and then you drop it to room temperature in a slow, controlled manner. And what that does is that it strengthens the material while removing the finishes that are rough or uneven on the surface. So it has two benefits to doing this at the same time. And a further thing that you can do to glass is tempering. So what tempering is instead of just making it so it's smooth like annealing, you heat it up past its annealing temperature and then you cool it very fast instead of slowly like annealing. You cool it with air jets. Usually, what they do when they make annealed glass or tempered glass, they process the glass and they roll it over some rollers where it heats up in an oven. And then in another room, it passes through, like right here, where the air jets will spray cold air at it rapidly. And what this does is that it allows the outside temperature to cool much faster than the inside temperature of the glass. So it hardens on the outside before the inside hardens. And then as it shrinks, that hardened glass then compresses in on itself and remains structured by its own shrinking force that it's applying on itself, similar to this image right here. The inside stays at a plastic region within its plastic region, so that way it stays a little bit more flexible, and the outside gets very hardened, so it can really resist a lot of scratches and any kind of dents that'll try to hurt the glass. And so this, a great way to think about it is if you have a balloon and you put paper mache over the top of it, the outside is going to be very hard, but the inside is still flexible. So that balloon can take a lot more resistive force without actually destroying the inside of it. And if you see on this figure to the left, you can actually see how the compressive forces actually work in its favor and increase the amount of PSI that the glass can take. And on the bottom right in this image that's really zoomed in, you can see that the tempered glass actually shows its compressive and tension layers when it breaks and cracks. So in conclusion, glass has come a long way from, glass blowing and spinning and mold making. Usually it started off as a decorative jewelry making or, beautiful dishes and bowls and cups. And then over time, we started realizing that it has a lot of very good properties like mechanical, electrical, and optical and thermal properties. So because of that, it's been really useful for shaping modern society. And it's everywhere now within our phones, on our car windows, and our telescopes to discover space. And we still have a lot more to go and a lot more to discover.